In this video, we'll be looking at how to find all the coordinates to be able to draw a graph, finding the midpoints, perpendicular and parallel lines, and using the graph to find approximate solutions and intersections between two graphs. An important fact to remember here is that when questions say to graph an equation, they mean for you to draw a line that connects all the coordinates that you've calculated. Before watching this video, you will want to familiarise yourself with the linear and quadratic equations videos, as elements of those videos are referenced quite heavily in this one. So let's remind ourselves how we got the graph for this linear equation. Linear equations always take the form y equals mx plus or minus c. In this equation, it's y equals 2x minus 1. So we know the value of our c is negative 1. And we use that for the y value when x is 0. We know that it increases as we go to the right by 2 each time because that's our gradient. So we can increase it by 2 to get the value of 1 and 3, and we can decrease it by 2 to go the other way and get negative 3 and negative 5. Now we're being asked to find the midpoint of this line. So in order to do that, you need to consider what the x values are in both the first and the last set of coordinates. We want to track the change in x, and then we're going to track the change in y. We want to do it as a vector from the lowest point. So if we look at our x values, we go from negative 2 to positive 2. So that's an increase of 4. For our y values, we go from negative 5 up to 3. So that's an increase of 8. So we can write it as half the change in x, which is 2, and half the change in y, which is 4. And we can write that as a vector. The change in x will be on the top, and the change in y will be on the bottom. So we're going to take our lowest coordinates, negative 2, 5, and we're going to times it by the vector 2, 4. And we end up with the coordinates of 0, minus 1. So that's our midpoint for this line. So here we've got the same equation of y equals 2x minus 1, and we're asked to find a perpendicular line that runs through negative 2, 2. Now a perpendicular line will run at right angles to the current line. There's a very simple way of finding out the gradient of the new line, because all linear equations, again, will take the form y equals mx plus c. To find the gradient for the perpendicular line, it's going to be the negative reciprocal of the current line. So in this case, we could say that it's going to start off with y equals negative a half times x plus or minus c. We need to find out what our c value is. Now we can do that because we're giving a set of coordinates that this perpendicular line runs through. So we can substitute those in. We can substitute 2 in for the y equals negative half times negative 2, which is our x value, plus or minus c. Now if we calculate those through, negative half times minus 2 would give us positive 1. Negative times a negative gives a positive. So we have 2 equals 1 plus or minus c. So now if we subtract 1 from both sides, we end up with 1 equals c. So we now have our y-intercept. And we can say that y equals negative half x plus 1. What we can do is we can now plot the points from that line. So we can plot negative 2, 2. We can also plot 0, 1. And we can then draw our line onto the graph. And we can see that it crosses our old line at a right angle. Here again, we have the same equation of y equals 2x minus 1. Let's just remind ourselves, y equals mx plus or minus c is always the way our linear equations are formatted. We're asked here to find a parallel line that runs through the coordinates 1, 3. Now the m, or the gradient, in a parallel line always remains the same. It has to. That's how come it's parallel. The thing that will change will be the c value, or the y-intercept. So we know that our parallel line equation starts off looking like y equals 2x plus c. Now we can substitute in our values of 1 and 3 for x and y, and we end up with 3 equals 2 times 1 plus or minus c. 2 times 1 will give us 2, so I subtract 2 from both sides and I'll end up with 1 equals c. So we end up with the equation for the parallel line being y equals 2x plus 1. We can plot the 2 points that we know, firstly 1, 3, but also we can do 0 plus 1 using our y-intercept. We can plot the other points like this and then draw the line in here. So our parallel line equation is y equals 2x plus 1. In this next case, we're given the equations as inequalities, meaning all the values to one side or the other of the lines are applicable. They use the smaller than or greater than symbols to show that. We'll draw the lines and then shade the area that fits the inequality. In order to calculate where the line is, we must imagine that the symbol is an equal sign to calculate the values of that line. So here, we've calculated the values of y equals negative 2x plus 2, starting with the 0 value and then working up and down. In this case, we draw the line here and shade to this side as all the values of y are smaller than or equal to negative 2x plus 2. Now we can look at x is greater than or equal to 0. We know that where x equals 0 is also called the y-axis, so the line will appear here. We'll shade the area to the right of it, as this is the area of x that's greater than 0. Lastly, we'll look at the inequality of y is greater than or equal to x minus 4. So we're going to start with the value of x equals 0, which is minus 4, and we'll increase by 1 each time and go backwards by 1. And so we shade all the values that are above this line. We can now see that the area that's shaded in all 3 inequalities, and we can shade that in darker than the rest to ensure that it's clear that this region satisfies all the inequalities. Next, we'll look to graph a quadratic equation. The result of any quadratic will always resemble a symmetrical curve, which is called a parabola. If the a coefficient is positive, it will form a U shape and extend upwards, and if the a is negative, it will form an N shape and extend downwards. Firstly, we need to calculate the coordinates as follows. I'll find out the 0 coordinate first because it's nice and easy. It's the c value from our equation, which is negative 5. Then it's really best just to start at the left-hand side and work your way across. So negative 3 squared minus negative 3 minus 5 will give us 7. Negative 2 squared minus negative 2 minus 5 will give us 1. Negative 1 squared minus negative 1 minus 5 will give us negative 3. Then we can skip the 0 because we've already counted that. 1 squared minus 1 minus 5 would give us negative 5 also. And negative 2 minus 2 minus 5 would give us negative 3. And lastly, 3 squared, take away 3, take away 5 will give us 1. So you can now plot these points and draw the graph. As I stated, there will be a symmetry to the curve that will be drawn on this equation, and we can see this in the numbers. Here we have the lowest value of negative 5, which means that the turning point of the curve will be between 0 and 1, because they both have the lowest value, and that's the turning point. Let's plot these points and draw the line. Notice that when I drew the graph, that the line has to be done freehand, as there should be no straight lines in this. Also, notice how the curve drops below the negative 5 at the turning point. Don't worry if your line is not exactly perfect. Examiners will be looking for the curve of the line. If we're asked to estimate the turning point of this graph, we can state that it's located at 0.5 and negative 5.3. This is just an estimation as we've drawn the graph freehand. They could also ask us for estimations of the solutions for x. Remember, this is where the graph crosses the x-axis, as this is where y equals 0. So using the graph we've drawn, we can estimate the answers for x to be negative 1.8 and positive 2.8. Now, we can look at how we can state what the intersections between two graphs are. This is the same as finding the solutions algebraically through simultaneous equations, but when done graphically. It's where the lines cross and the values for x and y at that point are the same in both equations. Here is what it would look like with two linear equations. Now what you can do is read off the coordinates of this point for the intersection. When looking at a quadratic equation and a linear equation, like this, we can see that there would be two intersections as the parabola goes through the linear equation and then returns. Both of these are intersections and need to be stated as answers. The exception to this is if the linear equation is a tangent to the parabola, in which case there would only be one answer, which is where the lines touch. We'll be finding these intersections in the next video, which is on simultaneous equations. So in this video, we looked at finding the coordinates and drawing the graphs from the equations, finding the midpoints, perpendicular lines and parallel lines, and what their equations are. We plotted linear and quadratic graphs to find solutions and also the intersection points. As I've said, the next video is going to be about simultaneous equations and how to find the value of two variables by using two equations that have those variables in them. I'll see you then.